So I will now present an analysis from the ALLATRA Global Research Center on additional factors contributing to the ocean heating. Let us now begin with the recent temperature records. From the spring of 2023 to the summer of 2024, the average global ocean surface temperature broke historical records daily. Dr. Rob Larter, a British marine geophysicist, commented, "It's quite scary, partly because I'm not hearing any scientists that have a convincing explanation of why it is we've got such a departure. But the impression at the moment is that things have gone further and faster than we expected." Professor John Abraham from the University of St. Thomas suggested that the previously unrecognized factors may be influencing the long-term ocean temperature trends, the factors that are not accounted for in existing climate models. As mentioned earlier, micro-nanoplastics may alter the physical properties of the ocean waters, effectively trapping heat within the ocean. But I want to point out that the plastic itself does not generate thermal energy. It only limits its release. This raises a fundamental question. Where does the heat come from? Recent studies show that the ocean warming is occurring not only at the surface, but also in the deep oceans. NOAA scientists reported that in the Argentine Basin, at a depth greater than 4,500 meters, the temperature increased by about 0.02 degrees Celsius between 2009 and 2019. Heating such a vast volume of water requires an enormous amount of energy, an energy equivalent to roughly 4 times Europe's annual consumption. A similar trend has been observed in the Weddell Sea off the coast of West Antarctica. There, the upper 700 meters showed little warming, while waters below 2,000 meters warmed at a rate roughly 5 times higher than the global average at comparable depth. Note that solar energy penetrates to the depth of about 200 meters, and even accounting for the vertical mixing, it rarely extends beyond 700 meters. Thus, solar radiation is likely not the explanation for deep ocean warming. So then, this leads to further question. What is driving the warming of deeper layers? A commonly accepted hypothesis proposes that the surface water are heated by the solar radiation and the atmosphere, with global ocean circulation transporting this heat greater to depths. But findings from a recent study at the Ocean University of China challenge that explanation. In this study, researchers identified what they termed subsurface marine heat waves, approximately 1/3 of which showed no surface manifestation. Another half appeared at the surface only during a certain phases of their development, while during other phases, they remained confined to the subsurface layers. If atmospheric heating were the sole driver, one would expect the thermal anomalies to first emerge at the surface and then propagate downward. Instead, observations indicate that some heat anomalies develop independently of the surface warming. These findings therefore suggest that atmospheric forcing alone may not fully account for the observed dynamics, and that additional energy contribution from below should